Hello, and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It is Tuesday, April 21st, and we have a seriously packed episode for you today.
We do. NASA has just pulled back the curtain on its next great space telescope, fully assembled and heading for the launch pad later this year.
Scientists are waving a giant bathtub ring at Mars and saying, this is proof there was once an ocean there.
The FAA has formally grounded Blue Origin's New Glenn rocket after what is now being called an official mishap. We have the latest.
SPHEREx, NASA's extraordinary 102-color eye in the sky, has begun delivering science, and the early results are beautiful.
Could your favorite exoplanet be a waterless greenhouse? New research has a sobering answer for many worlds in the habitable zone.
And we'll look at what spaceflight does to the human brain, including why those effects don't always go away when astronauts come home.
All of that and more. Let's get into it.
Ready when you are. Take it away, Anna.
Our first story today is one of those moments you want to remember. On Tuesday, NASA opened the doors of its giant clean room at the Goddard Space Flight Center in Greenbelt, Maryland, and invited the world to meet the fully assembled Nancy Grace Roman Space Telescope, one of the most powerful observatories humanity has ever built.
I have been following this telescope for years, Anna. This is such a big deal. What are we actually looking at here?
So the Roman telescope is NASA's next flagship, its successor in many ways to Hubble and the James Webb Space Telescope. It's been fully integrated now, meaning its two major components, the telescope itself and its instrument package, have been joined together. And today was one of the last chances anyone outside NASA will have to see it before it ships to the Kennedy Space Center in Florida.
And the launch is getting close, right?
Very close. NASA is targeting a launch as early as this coming fall, and the team says they are on track for that. The mission is officially scheduled no later than May 2027, but fall 2026 is looking genuinely achievable.
And remind us, what is Roman actually going to do? Because it has a very different mission to Webb.
Great question. Roman is primarily designed to survey huge swaths of the sky rather than staring deep at single targets the way Webb does. It will map hundreds of millions of galaxies, probe the nature of dark energy and dark matter, and search for thousands of exoplanets using a technique called gravitational microlensing. Its field of view is roughly 100 times wider than Hubble's, which means it can map the cosmos at a scale we've simply never been able to do before.
100 times wider. That is extraordinary. It's like going from a magnifying glass to a panoramic window.
Exactly. Roman will essentially give us the big picture that Webb can't. The two telescopes are designed to complement each other perfectly. And today's reveal was one of those reminders that it's really happening. The telescope is done, it's real, and it's almost ready to fly.
Incredible. The universe's next great detective is suiting up.
All right, where do you want to take me next, Avery?
Well, I want to take you to Mars, and I want you to imagine draining a giant bathtub.
Okay, I'm imagining it. This is a very large bathtub.
Planetary scale, because that is essentially what researchers at Caltech, California Institute of Technology, have been doing. They published a landmark study in the journal Nature this week, and they found what they're describing as a bathtub ring around the northern hemisphere of Mars. A flat, shelf-like band of land up to several hundred kilometers wide that wraps the contours of where an ancient ocean may have once met dry land.
So this is evidence of shorelines, or more precisely, continental shelves?
Exactly, and that distinction matters. Previous research had identified features that looked like ancient shorelines, but those were found at varying elevations, which was a problem. A real shoreline should be level. So the Caltech team, led by former postdoctoral scholar Abdallah Zaki and geology professor Michael Lamb, took a different approach. They asked, instead of looking for shorelines, what if we look for the continental shelf itself?
Because on Earth, the shelf is much more stable and durable than the waterline.
Precisely. They first modeled what Earth's oceans look like without water and found that the most reliable signature is that flat, wide band of land at depth, the coastal plain and continental shelf. Then they looked at topographic data of Mars from orbiting spacecraft, and they found exactly that. a flat zone in the northern hemisphere consistent with a coastal shelf of an ocean that once covered roughly a third of the planet's surface.
A third of Mars? That would have made it look almost Earth-like.
And crucially, the river deltas that geologists have already mapped on Mars, those triangular plains where ancient rivers flowed into something larger, line up beautifully with this newly identified shelf. Everything is telling the same story.
And the implications for life are significant.
Enormous. If Mars had a stable ocean covering a third of its surface for potentially millions of years, then its northern lowlands may have been inhabitable. And those ancient coastal sediments could have preserved biosignatures, the same way coastal sediments on Earth do. The ESA's Rosalind Franklin rover, expected to land on Mars in 2030, will explore this exact region and could provide the definitive answer.
Mars, it turns out, may have once had a bathtub ring you could see from space.
And that, Anna, is the best kind of geological metaphor.
Now, yesterday we told you about Blue Origin's New Glenn rocket and the difficult mission it had on Sunday. As a quick recap, New Glenn launched successfully, the booster landed successfully for the second time ever, historic, but the upper stage failed to deliver the AST Space Mobile Bluebird 7 satellite to its intended orbit. The satellite was lost.
And today there's a significant development because the FAA has now formally stepped in.
It has. The Federal Aviation Administration has officially classified Sunday's event as a mishap, and that word carries real regulatory weight. New Glenn is now grounded. It cannot fly again until Blue Origin completes a full investigation, reports its findings, and the FAA determines that the cause of the failure does not pose a risk to public safety.
So what do we know about the cause? Has Blue Origin said anything?
They have. CEO Dave Limp posted a statement saying that early data suggests one of the BE-3U engines in the rocket's upper stage failed to produce sufficient thrust during what's called the second GS2 burn, a maneuver needed to circularize the satellite's orbit. The engine underperformed, the burn fell short, and the satellite ended up at roughly 150 kilometers altitude instead of the planned 460 kilometers, far too low to operate.
And it's not just the FAA watching. NASA, the National Transportation Safety Board, and the U.S. Space Force are all monitoring the investigation as well.
Which tells you how seriously the industry is taking this. Blue Origin had up to 12 more New Glenn missions planned for 2026, so the clock is ticking on getting the rocket back in the air. And for AST Space Mobile, whose constellation of direct-to-smartphone broadband satellites depends on launches like this, the setback is significant, though the company says the satellite's loss is covered by insurance, and that 3 more Bluebird satellites will be ready to ship within 30 days.
A reminder that in rocketry, even the successes can contain failures, and vice versa. Blue Origin had a genuine historic milestone on Sunday, and a genuine setback.
We'll keep watching how this investigation unfolds. Now, Avery, before we move on to our next story, I'd like to give a shout out to our sponsor. You know, the folks who help keep our podcast afloat. And today's episode is brought to you by NordVPN. They have some incredible deals for our listeners at the moment. So if you're looking to secure your online privacy, I would highly recommend NordVPN. There's a link in the show notes.
Okay, moving on. Let's go from a grounded rocket to a very much ungrounded space telescope. Because SPHEREx has begun delivering science, and the early results are stunning.
SPHEREx, for our newer listeners, that stands for Spectrophotometer for the History of the Universe, Epoch of Reionization and ISIS Explorer. And it launched just over a year ago in March of last year.
And what makes SPHEREx unlike any telescope we've ever flown is this. It observes the entire sky, the whole thing, in 102 different colors or wavelengths of infrared light. It takes roughly 3,600 unique images every single day and is weaving them together into all-sky maps that will eventually chart hundreds of millions of galaxies.
So what has the first published science shown us?
2 things of huge interest. First, ice. SPHEREx has mapped the chemical signatures of interstellar ice, including water, carbon dioxide, and carbon monoxide, across star-forming regions of our Milky Way, including the turbulent stellar nursery known as Cygnus X. These microscopic ice crystals, coating tiny dust grains in space, are where most of the universe's water forms and is stored. The water in Earth's oceans, the ice on comets, it all traces back to regions like these.
Which makes SPHEREx a telescope that's literally mapping the origins of water and possibly of life.
Exactly. And second, it has mapped polycyclic aromatic hydrocarbons, complex organic molecules sometimes called the universe's most common carbon compounds, throughout the same regions. These molecules are thought to play a role in prebiotic chemistry, the chemistry that sets the stage for life.
So right out of the gate, SPHERex is looking at the building blocks.
And it's only just begun. It has 2 years of planned survey operations ahead. And by the time it's done, it will have produced 4 complete all-sky maps. Combined with what the Roman telescope will do, surveying galaxies at vast scale, we are about to enter a golden age of sky surveys.
I love the idea of a telescope that sees the whole sky and colors our eyes can't even perceive.
102 shades of the invisible. That's SPHERex.
Now, we talk a lot on this show about planets in the habitable zone, that Goldilocks region around a star where liquid water could exist on a planet's surface. But new research published this week asks a harder question. Is being in the habitable zone actually enough?
And the answer is not necessarily.
Not even close, it turns out. The new work highlights something that sounds obvious once you hear it, but has significant implications for how we search for life. A planet in the habitable zone still needs substantial water to maintain the carbon cycle that keeps temperatures stable. Without water, even a perfectly positioned planet can become a runaway greenhouse world, a Venus-style hellscape, regardless of how close it sits to its star's sweet spot.
So water isn't just important for life to drink, it's important for regulating the climate that makes life possible in the first place.
Precisely. On Earth, water plays a critical role in the cycling of carbon between the atmosphere, oceans, and rocks, a process that has kept our planet's temperature remarkably stable over billions of years. Without sufficient water, that cycle breaks down. Carbon builds up in the atmosphere, temperatures spike, and you end up with a planet that is technically in the habitable zone, but is very much not habitable.
Which changes how we should be thinking about candidate worlds.
It does. Simply finding a planet at the right distance from its star is no longer enough. We need to be asking how much water that planet has, and whether it's retained enough to keep its climate engine running. It raises the bar for what we call a truly Earth-like world, and it makes our own planet's long geological relationship with water look even more extraordinary.
Earth really did win the cosmic lottery.
Several times over.
And now, for our final story today, I want to get personal. Specifically, I want to get inside an astronaut's head. Literally.
I feel like this is going somewhere I should be concerned about.
Only slightly. A new study has found that spaceflight changes the human brain, not just temporarily while astronauts are in orbit, but in ways that can persist long after they've come home to Earth.
We've talked before on the show about the physical toll of spaceflight. Muscle loss, bone density changes, fluid shifts. But what specifically is happening to the brain?
So the study, published in the Proceedings of the National Academy of Sciences, found that after extended spaceflight, astronauts' brains are physically shifted in position inside the skull, tilted upward and moved back relative to their normal Earthbound position. And the areas most affected are the sensory-related regions of the brain, the ones responsible for balance, spatial orientation, and motion processing.
Which explains, presumably, why astronauts often feel disoriented and have balance issues when they return.
Exactly. But what makes this study particularly striking is the persistence of these changes. This isn't a short-term adaptation that bounces back the moment gravity reasserts itself. The researchers found lasting neurological impacts, suggesting that the microgravity environment genuinely rewires some of the brain's fundamental processing systems over time.
And the implications for long-duration missions to the Moon or Mars are profound.
Enormous. If astronauts are heading to Mars on a 7-month journey each way, with months of surface operations in Martian gravity, which is only 38% of Earth's, we need to understand what is happening inside their brains, not just their muscles and bones. This research adds to a growing field of aerospace medicine that is trying to make sure the humans who travel to the stars can also function effectively when they get there and when they come home.
It is both a little unsettling and deeply fascinating.
That is the definition of good science, I think.
Well said.
And that is our episode for today. What a show! From the Roman telescope reveal to a bathtub ring on Mars, a grounded rocket, a 102-color map of the Milky Way, the secret ingredient that makes planets truly habitable, and what spaceflight is quietly doing to the astronaut's brain.
You can find us at astronomydaily.io and across social media at AstroDailyPod. If you enjoyed today's episode, please leave us a review. It makes an enormous difference to the show. And don't forget to give our sponsor link a click. I think you'll be glad you did.
And as always, keep looking up.
We'll see you again tomorrow.